Buenos días, soy Sam. Voy a dar a mi charla en inglés para facilitarlo. Ainda tengo que estudiar más, hacerlo en galego. So this talk I gave in the distributions dev room in FOSDEM. So it was an audience of Linux distribution developers. And my point to them was, you guys, Linux distribution developers, need to collaborate more with upstream projects on testing. Here the audience is different, right? There's any distribution developers? One, okay. But I won't give the talk just to you. Which distribution? Okay, okay, excellent. So, and one more. So I'll go a bit more into how distributions are tested and what's the state of the art in end-to-end testing, rather than trying to redeliver the original talk. The original talk was quite optimistic. I was talking about where things could be in 5 years, rather than where things are now. But I think today I'll talk a bit more about where things are now. Okay, a quick competition, right? What year did you install Linux first? Anyone before the year 2000? Okay, before 1998? One or two. Wow. What year? 95? 96. How well did it work in those days? Yeah, I think I first installed Linux in the late 90s, 2000s, and it was a game, right? You're like, okay, it's installed finally. Now I need to fix my Xconfig to try and get a graphical desktop. And then let's see if we can make audio work. And then if you could get Wi-Fi to work, that was incredible. So things have progressed a lot since then. Now you can install Ubuntu or Debian or Fedora, and you mostly expect it to work. And one of the big improvements is that we actually test things now. We have automated testing in most of the distributions. And we've been testing software for a long time. Everyone knows about unit testing, right? Where you isolate a small piece of the software and you mock the rest of the software, and then you go, okay, yeah, this unit works. The rest of it we don't know, but this unit works. End-to-end testing is the kind of the opposite of that, where you try to cover absolutely everything. So in the case of an operating system, that means you have to test the kernel, the user space, the graphics stack, everything. You don't have any mocks. And in the case of an operating system, that means you have to install it in a virtual machine or install it on real hardware, even better. So that's one aspect of end-to-end testing. The other important detail is using the system like a real user would. So not, in the case of an operating system, not just firing commands down a serial console, which is not how we interact with a desktop. It means sending keyboard events, sending mouse events like a real user would, sending touch events now, and looking at or visually scanning the display to see what is output. So, if a blue button that says find this software for appears, use image matching to check that that really appeared, and then send a mouse event where it is to click the button. So distributions that are doing this today, Debian is one, actually. Debian's doing end-to-end testing. Fedora and OpenSUSE, kind of the innovators here. And OpenSUSE developed a tool called OpenQA, which is the tool most distributions have standardized now. So this is a list of all the distributions we know about using OpenQA. And I'm going to quickly try and show you one of them. So this is the Linux QA project, which is where we try and collaborate on between the different distributions doing testing. And we have a link to everybody's tests. So this is Debian's OpenQA instance. And if we go to a build from today, they're testing all the different desktops, well, some of the different desktops that you can install in Debian. So we're going to go with GNOME, obviously. And actually, let's look at this one, GNOME apt start stop. So this is a test suite which tries to start every app in GNOME. Oh, it's actually running right now. That's really exciting. So we can watch the test running live. But it doesn't seem to be doing anything. So maybe we won't watch it live. Yeah, let's go to a different one. Let's have a look at Emacs test. I wonder what that does. Okay, so it kind of does what you expect, I suppose, that, and we can flip through the screenshots. The machine boots, verifies that the login screen appears, and one of these presumably is going to log into the system. Okay, so it's used image matching to find the password box. I guess down here it's typed in the password. Yep. And then further down it logs into the GNOME desktop. It's exiting the activities view, and then spoiler, it's probably going to start Emacs somewhere along the line. So yeah, there we go. And they've tested, okay, Emacs is opened, very good, and that's the end of the test. Another cool thing about OpenQA is it records a video. So you can watch this in, it's not real time, it's sped up, but we can see what happened. So that's the machine booting, the login. This is probably installing Emacs, right? Because it's not in the default Debian distribution. So you get to watch it install Emacs, go back to the main screen. This is a cheat, that's not how you'd actually launch it. And there it is. And even edit some text. So this is kind of the state of the art in distribution testing using OpenQA. And it's really cool, right? It's, we've come a long way since the days when the end users were the testing team. Right, now I have to go back to the slideshow. I always forget how to do. Slideshow, Control F5. So that's the good part, right? The not so good part is there's very little communication at the moment between the people developing the software, like the Emacs developers, for example, and the downstream integrators who are developing the tests. So what happens a lot is that every new release, not so much with Emacs, but every new release of GNOME, for example, the UI changes slightly, the screenshots go out of date, and the downstream has to update the tests. Or a lot of the time, it can happen that the app changes functionality, like maybe they remove a feature, and it's not clear downstream, is that deliberate or is that a bug? So you have to go and ask, like, did this change deliberately? So I've written up here kind of the idealized Linux distribution development model, where developers such as the GNOME project release source code, and then the downstream integrates that and releases a binary to the end users. And then this is the part that's total fantasy. The end users' support requests go back to the downstream, go back to the distribution, and the distribution developers will, work with the upstreams to report and fix the bugs. This kind of works in commercial distributions. In the volunteer-powered distributions, it's a bit more complicated. So it would be interesting to make this model work better. And one of the blockers to this model today is that there's long delays involved. So you're an upstream volunteer app developer, you've implemented a new feature at the request of some user who said, oh, I need this feature. Yeah, okay, I'll write the feature. And then the end user says, how can I install it in my distro? Well, wait 2 years and then it'll be released. So just developers upstream have now kind of started working around this with Flatpak to release things directly to end users, for better or worse. And it's really a symptom of the delays in the existing model. So if we could improve the automated testing, if we could automate some of the work that downstreams and upstreams do, then perhaps we can make things go faster. That would be the idea. So my introduction to this world was in 2021, when I'd recently started back working at CodeThink, and they said, oh, we've made these OpenQA tests for GNOME, but they're not finished. Can you finish them off? So I got involved there for a few weeks, And I thought, that was my first time working with OpenQA. And I thought, wow, this is really cool, actually. So we set up an OpenQA instance, like the web UI in the GNOME infrastructure, and set up these basic tests, and kind of took it from there. So from that point on, it's been mostly me and bits of downtime, and we did an internship 2 years ago, which added a load more tests, and also forced me to improve a lot of the contributing guides and so on to make it more accessible to newcomers. It's still maintained by volunteers, so it's often broken, but we do now have some level of end-to-end testing upstream in GNOME. Some of the challenges involved is, of course, GNOME isn't a distribution. It's a desktop environment that different distributions all integrate. And it doesn't favor any distribution. So there are paid contributors in GNOME from at least 4 different distribution companies. And so it's not as simple as say, oh, we're going to test GNOME on Fedora, right? Because that will make everyone who doesn't work at Red Hat a little bit angry. We can't say we're going to test GNOME on Ubuntu, because again, that will make everyone who isn't from Canonical a little bit angry. So the solution is, of course, for GNOME to make its own operating system. That now exists. It's called GNOME OS. It's not a general purpose distribution. You can't even install packages, right? It specifically exists for you to run the latest possible version of GNOME. So everything's built from master. It's usually broken because, of course, everything's built from master. It's great for testing, great for seeing like the newest designs of what's going to be in the next release of GNOME. I wouldn't recommend installing it on your sort of main laptop, unless you like fixing bugs. But it's great for this kind of end-to-end testing because it's exactly what we want to test, right? We want to test the freshest thing that people have just written. So that was one challenge, but there's a few volunteers maintaining GNOME OS, so that part's kind of solved. Then the other challenge is infrastructure, because a modern operating system is about 4 gigabytes in size. And if you want to build a new operating system, that's another 4 gigabytes. And you have to store them somewhere, right? So there's an infrastructure question. At the moment, GNOME gets free AWS credits, so we solve it by letting Amazon pay for things. That's maybe not a long-term solution, that's the current solution. And also, running the integration tests requires some hardware to run the tests on. Even if you're running it in virtual machines, like that's a little bit complicated because you need KVM support. So we kind of worked around that for the moment as well, which I'll go into in a bit. But we did kind of get there. So let me show you what GNOME has today. This is going to be a little underwhelming because it's currently very broken. Also, I don't know why this happened, but I'll just type it in rather than clicking the link. So this is GNOME's OpenQA instance. It's the same as all of them, except it has a foot on the right. And we go to all tests. So recently GNOME changed all of the fonts, which means that the tests are completely broken. And this is an interesting problem because it's completely within reason, right? That the thing you're testing changes and you have to update all of the screenshots. So the tooling needs to support that. And it's possible, but that's kind of my current focus, is seeing how we can make this less painful. So let's go back in time to 2 months ago and look at some of the tests that we have. This is the GNOME apps test, where, very basic, I'll make it a bit bigger. We try and start every core app of GNOME and just check that it looks the way it's supposed to look, right? So that's the disk usage analyzer. There's the characters app and so on. This is a really useful test in itself because GNOME applications are written in about 8 different languages. So if someone breaks the JavaScript bindings, for example, and 3 of these apps will stop running, and things like that. So it's already a really useful test, just opening the apps. But we don't go as far as actually getting the apps to doing things with the apps for reasons I'll go into. There's another one where we just install GNOME OS and check that it works. Again, let's see if we can watch the video of this one because it's kind of cool. That's probably a web server issue, which again, I get to fix. So that's how OpenQA displays the test results. And then I'm going to quickly show you how the tests are defined. First, we have to prove that we're not a bot, because there's another story here, right, which is that AI scrapers are currently destroying infrastructure of all open source projects, so that we're having to put up these kind of proof of work challenges. This is the repo which has the tests. And spoiler, OpenQA is written in Perl and the tests are written in a DSL, but the DSL is a DSL of Perl. You don't really need to understand much Perl to be able to write tests, but it does put some people off that it's using. Some people like actually that it's in Perl, and other people hate it. I personally don't feel very strongly. So to show you a little bit about what the tests look like, probably one of the more complicated is this one, which installs GNOME OS, but it's not complicated at all, right? A certain click, can I make this go away? I'll just make it a little bit smaller. A certain click is a function to say, wait for the screen to look like this. There's a screenshot which has a tag GNOME install 1. We wait for 120 seconds because we're actually waiting for the machine to boot here, which might take a couple of minutes. And then there's a click point marked within this screenshot, it's called a needle. And so when it appears, click the left mouse button on that click point. Then do the same thing with this one, do the same thing with this one. Eject the CD. It's an ISO, so it's not a real CD, but you need to do that on the virtual machine, and then reset the machine. So that's a fairly simple OpenQA test. And the domain-specific language is fairly straightforward. Unfortunately, you can also run arbitrary Perl code. And so when you look at the tests for things like OpenSUSE, there's loads and loads of like stuff they've built in the background, which is, you know, custom Perl code that is often not documented either. So things can get a bit more hairy than this, but they don't need to. So let me show you the needles repo as well quickly, since I've shown you the tests. That's the missing piece of the puzzle. So needles are screenshots with some metadata. So the GNOME install, maybe we can't see all of them because there's so many files in this repo. State of the art is commit them all into a single Git repo. Again, maybe that can be improved. And the other kind of convention is that every time you update it, you keep the same name, but you add a date. So when there's a visual change, you take the same thing and just add the date. So GNOME install 1, that's going to be an old one. Let's open this one. You can see GitLab's actually slowing my browser down a bit. Okay, so that's the screenshot, GNOME install 1. And there's a newer version, which they changed the desktop background, so we had to update the screenshots. The metadata, in fact, yeah, that's incorrect. It's not because they changed the desktop background. I'm not exactly sure what changed. This text changed. Yeah, and the spacing changed slightly. So this defines what's called a match area, and it's just a rectangle. And the rectangle defined here will be probably this window, so from here to here. So you don't match the entire screenshot, you just match, you know, the area you're interested in. And ideally you match the smallest part of it so that the tests don't break. So ideally you'd kind of just match this text or match this header or something. And then the click point is on this button, so that's defined here. In fact, yeah, this is just matching the button. So you match this button, then you click it. So I've gone a bit into detail of how this works, but I think it's useful to see, you know, see behind the scenes as well as just seeing the web UI. Apart from that, OpenQA is designed for use initially in OpenSUSE, right, which is a company with money to pay for servers and infrastructure. To simplify things in GNOME, we use our GitLab CI runners as the workers, which is a bit of a hack. So we have some glue code instead of having to maintain separate test runners, we use the GitLab CI runners. And it works kind of nicely, but there's also some rough edges. And I think long term, we just need to get someone to pay for infrastructure and have dedicated test machines. And GNOME build meta is a special repository inside GNOME which tracks the version of every component. So that's the repo you can look at and say, what is in this release of GNOME? And so when you build that, there's a CI pipeline. In fact, I'll show that as well. Although, again, I failed to click the link. Because I need to do this. So GNOME build meta, every time you make a commit to update the version of whatever piece of software on the master branch, then it runs a build and it runs the OpenQA tests. So that would appear somewhere in here. I need to filter down to the master branch. Never do live demos, they say. Branch name, master. Okay, yeah, so update element refs, for example. So you have the test OpenQA desktop job and the test OpenQA installer, and then if those succeed, then it uploads the new image as kind of a tested image. So it's cool that this is all integrated in the CI pipeline. And from there, you can open this. It's a normal GitLab CI pipeline, but it links you to, oh, actually that one's, don't look at this because that one's broken. But generally, it links you to the OpenQA job in the OpenQA UI. So that's the state of the art today. But what's the problem? The ideal was that everyone in GNOME would find this useful, right? And in practice, currently we are 2 contributors. So something's missing. And when I talk to people in GNOME, people who develop apps, and I say, what is missing? They say, well, people send me merge requests, and I review the merge request, I merge it to master, and then you test it. So you find the bugs after I did the code review. So what maintainers want is they want to run this QA testing in the CI pipeline. You send a merge request, the test happens there before they have to review it. So the next step is thinking, how can we do that? We did some research into that last year, and we decided to focus on GNOME Shell, mainly because it's the most complicated case. So the thinking is whatever works for GNOME Shell will work for anything else. And one of the big problems here is time, because if we look at a kind of naive way to build an OS with a version of GNOME Shell and test it, first we have to build the OS image. That's about 45 minutes, and it's limited by I/O, right? So even on a fast build machine, you have to copy 4 gigabytes of data around. It's not that, you can't make that super fast. Then you have to download the image onto the place the tests are going to happen. For reasons, that takes about 10 minutes, because the images are in Amazon Web Services and then the runners are somewhere else. So again, that's an infrastructure issue. You have to run the installer, which is about 2 minutes, and then you have to go through initial setup, which is 20 seconds. So we're looking at almost an hour to run each test. That's not very good, right? You can only run 8 tests in a day. So how can we make this a bit faster? I'm going to skip the video because I've shown it to you. The only way to make image building fast enough is don't build the image, right? We already have image builds of GNOME OS. Every time someone updates that, we have an image. So what if we could build GNOME Shell, just GNOME Shell, or the thing we want to test, and overlay it on top of the existing OS image? And there is a nice way to do that, which is distro independent. It's very new. It's built into systemd, and it's called a systemd sysext. And it's like a really basic package. It doesn't have it doesn't track dependencies, so it's not usable in the way a Debian package is. But it's great for testing because it's really simple. It's just a binary, and it's pretty much just a binary. So I've jumped ahead. So what we can do is download an existing OS image, build GNOME shell in the CI pipeline, inject the binary on top, and because it's built into systemd, we can do that as the system boots. So this kind of testing works for pretty much anything except systemd itself. What it does is it makes an overlay FS. Right at boot time, overlays the sysext on your root FS, and then go. So that's great. We've saved 45 minutes. Downloading the image is an infrastructure problem which requires money to solve. So that's as yet unsolved. We don't need to run the installer actually, because we can build a hard disk image that's already got the OS installed. So that's another 10 minutes free. And then we also looked at how to bypass initial setup using a thing called the SMBIOS to inject some configuration to systemd so that it creates the user right away. That's recently, very recently landed in systemd. So now we can get rid of that step as well. So the prototype that we got running last year, this is from the real GNOME shell CI pipeline. The build part actually landed in GNOME shell master as well, and so they are building sysexts now. The testing part still has a few blockers, so that's kind of still a prototype. But it's possible. And I think it's quite exciting. The GNOME shell developers think so as well. So what's still to be done? Creating the temporary user, which I told you about. Getting more infrastructure, which is a really sticky problem. And teaching people how to use OpenQA and how to write OpenQA tests, which is maybe my focus for the next year. And from there, this is where I wanted to appeal to distributions developers, is how can we think about this more, not just in GNOME, but over the whole sort of Linux development community? And part of this goes back to how OpenQA was, the people who are paid to work on OpenQA work at OpenSUSE, and they have their problem to solve, which is testing OpenSUSE, testing the enterprise SUSE Linux. So for the purposes of a more distributed project like GNOME, there's changes needed in OpenQA. And one of the big changes, I think, is being able to share more stuff, rather than you have, like at the moment, there's maybe 10 OpenQA test suites in the world, right? There's the SUSE tests, the Debian tests, the Fedora tests. The Debian tests are mostly copied from the SUSE tests in practice. So there's a lot of copy and paste. There's not much standardization. And the next step is making a kind of shared base for Linux QA testing. Like another interesting thing about OpenQA is that it's totally generic. It's not actually specific to Linux. You can install Windows in a VM and test Windows stuff if you want, because all it's doing is taking screenshots and injecting mouse events into the VM. So it's not Linux specific. But that also means that when you want to do Linux specific stuff, currently you write your own custom code. So you want to connect to the serial console and wait for a login prompt. You need to copy and paste this, which has some battle scars, right? You can see from the comments that someone had to figure out that you have to eat the stale buffer contents first and send a return key and so on. And none of this is shared at the moment. So I think the focus here should be making a shared base. It'll probably be a Perl module in practice that you'd install along with your tests, where different distributions can collaborate on making a shared base. And then, as we add more and more tests into GNOME, remember that in GNOME there's 200 modules, right? So if each of those has an OpenQA test suite, we've copied and pasted this 200 times, which I very much don't want. I don't want people saying, oh, how do you fix this? Well, which of the 200 different versions do you have? The other thing we need is infrastructure. And open source infrastructure is having a difficult time at the moment, as well as being abused by lots of AI companies crawling kind of crazy stuff. There was a company called Equinix that was sponsoring a lot of ARM hardware, who have, for business reasons, decided they're not going to do that, which is affecting, well, freedesktop.org and GNOME and various other projects. So at the moment, when we're looking for infrastructure sponsors, firstly, we're trying to replace this to get back to where we were. And then maybe later we can find people to pay for infrastructure to run QA tests on, which I don't think is that demanding, really. Any kind of server can do this. So if anyone has a spare server, talk to me and we can have some fun with it. And I've already shown you a lot about OpenQA's test DSL, but there's quite a lot of improvements to be made there. Personally, I'd like a command line tool rather than the way the people at SUSE do it is they run the web UI on their laptop in a container and they develop tests that way. And then when they open a merge request against the main SUSE tests, they say, here's a screenshot from my personal instance, or here's a link to something on the LAN. So rather than that, the ideal would be a sort of a command line app or a VS Code plugin or something that you could use to develop tests. Again, fun project if anyone wants to work on this. And finally, I think the end goal, this is the optimistic part I mentioned in the beginning. Imagine if, when GNOME makes a release, it comes with tests, OpenQA tests or whatever tool succeeds it, and the packages downstream can run those tests against their integration. So in Debian, you could say, okay, we've integrated the new version of GNOME. Now we're going to run their tests and see what passes and what fails. And that gives you a way to speed up integration of GNOME, right? Rather than having to manually update the tests. If you can reuse the screenshots and reuse the tests from the upstream project, we all win, I think, in theory. So yeah, the hardest problem in software development is getting people to talk to each other and agree on things. So to that end, my main contribution at the moment is running a monthly call where people from different distributions meet up and talk about this stuff. It happens the first Thursday of every month, open to anyone who wants to join there. The time zone switches to allow people in the US to join and people in Asia to join. And it's going pretty well, actually. There's quite a mix of people. I've met people from Debian, Red Hat, Canonical, Amazon. Amazon are actually making their own Linux distro and they're adopting OpenQA. And a few other places. So it's always different every month. It's an interesting call to join if you're interested in this stuff. And hopefully, eventually, we'll make progress on these tasks. So that's it for the talk. And hitting the questions.
So end-to-end testing is, as we have seen in the examples, is usually essentially complex and a bit brittle sometimes.
Yeah.
So many people think that the confidence on our software should come from what they call a pyramid of tests, where the base are unit tests and end-to-end are only the top. There should be few and very focused on testing that the glue between things works, but not on testing the actual behavior. You as a maintainer of this kind of tool, what's your take on this? Do you have the same opinion, or do you think that end-to-end testing should have more weight, more specific weight?
Yeah, in short, I completely agree. I think the pyramid is a useful concept, right? Because we're missing the top of the pyramid, essentially. It's easier to write unit tests, and it's easier to write integration tests. So, I mean, distributions already run the unit tests, for example. Debian run a package's unit tests, which is really nice, but it doesn't catch the complex bugs. So, yeah, the reason I want to focus on this is just because it's the hardest part, and so it's the bit that's missing, really. But there's definitely layers. For app testing, there's a project called Appium, which is interesting because instead of graphical testing, it uses the accessibility APIs. So that's really cool, right? Because firstly, your accessibility APIs have to work. And secondly, you don't have the problem of somebody changed the font and now I have to update the tests. But it doesn't catch bugs in your rendering pipeline. So you need both, really. In the ideal world, we'd have everything.
All testing and apps are made in Perl or something like
The tests are all in Perl.
in Perl.
Yeah, you can write in Python, but it's a weird, like, Python within Perl. So for me, I feel like now you have two problems. I'd rather use Perl directly.
Yeah, the question is a bit general. There is the general problem of brittleness,
Yeah,
and I see many sources of brittleness in this. We have we needed to do a tight control of the environment, since, for example, the background could interfere if you do pixel by pixel testing.
yeah,
There is the problem of timing. That is, you're putting fixed amounts of time for waiting for some condition to be satisfied.
yeah.
So I see many sources of brittleness, and what I'd like to know is what's your general approach to reduce brittleness to make this more amenable to a wider array of users that you're intending to convince to use the
Yeah.
OpenQA.
Good question. You can see the problems in advance. And so to be clear, like SUSE have been using this since 2010 or something. So they've encountered all of the problems. And for timing, generally the fix is just use dedicated hardware. Because we have this problem in GNOME that we run on the CI runners and they're shared machines with a high load. It's mostly fine, but yeah, if there's a load problem, then the I/O changes, it goes slow, and now that it maybe times out. I think the best fix for that is just use dedicated hardware so that it's more predictable. In terms of the screenshots, there are a few tricks. Firstly, it's not exact pixel by pixel matching. It's using OpenCV, and it has an algorithm to calculate a similarity percentage. In fact, let me open up the web UI because this could be illustrative. I open up a test that failed. Yeah. I'm going to have to log in though, which is going to be annoying. But I'm going to do it to illustrate the point. Oh no, I am logged in actually, so I should be able to edit this. Right. If I'm logged in, why can't I edit the test? It's confusing. So this is the web UI, and it has tools in theory, although I can't open it for some reason, but it has an interactive tool for editing the screenshots. So the first kind of defense against the screenshots changing is make it easy to update them, because there's no 100% solution. So make the pain less, effectively. Make it so to update the screenshot, you click a button and you go, new screenshot. Okay. Let me see if it appears here. No, it doesn't. Don't know what's happened here. There should be a needle editor which opens up and lets you say, okay, I'm going to update. The other trick is similarity matching, like I said. So you can see here, there's a 96% match rate, and you can configure that. You can say, okay, 90% is okay, or 80% is okay. Apparently, if you go to below 80%, it's not much useful to match anything. And then the other trick, which is match the minimum thing. So if what you want to test is, did GNOME web appear? You can just match the word web here. And it doesn't matter if this changes color. You know that, okay, the word web appeared, so we can assume the browser opened. Or, just match the navigation bar. So you match the minimum area rather than the big screenshots. And this actually, it makes sense because when you think of how an end user uses an application, an end user doesn't look pixel by pixel. Like an end user is trying to achieve a task. Like, okay, I want to close Gnome Web. How do I do it? I click on the X. So the user is going, where's the X? Okay, I click the X. And if tomorrow the X is over here instead, OpenQA will match that. It searches the whole screen and goes, where's the X? Ah, here's the X. I'll click the X, which is what a user would do, right? If you update the app and the button has moved, you go, the button has moved. I'll click it here. It's not broken. Whereas if the button is missing, that is a problem. So there's an art to constructing these tests and saying, okay, what am I trying to test? I'm trying to test this button. So I'll only match this button and nothing else. And then only that thing can break. So yeah, it's a good question because there's an art to using this software. And definitely, it's better to use unit tests if you can, right? You use these for things where it's lots of things integrated together and it's really hard to test any other way.
And how do you create the screenshots in the first place? Is that something that you need to do manually and commit to the repo, or is it something that you can do from the OpenQA tool? How does that work?
Yeah, I think this needs to improve. There is a way to do it in the web UI, which is called developer mode. On the GNOME instance, it doesn't work for infrastructure reasons, but that's the way people at SUSE do it, for example. You write a test, the test fails because there's no screenshot, and then you can step through the test and say, okay, in developer mode, it will say, the test failed, do you want to update the screenshot or do this? You go, yeah, update the screenshot, save it, and continue. So when you write a test, you can step through it and have the machine open. What I do is I do it manually. Usually I have the virtual machine running on my laptop, and I have a VNC connection open, and then I can capture a screenshot from there. So I have a custom tool I wrote, which is open, but it's not particularly polished. So that's another way to do it.
So what happens with distributions that don't use OpenQA? I didn't see, for example, Ubuntu or Alpine there. So how does it go?
They break more often. No, in the case of Ubuntu, they are thinking of adopting this. I don't know what they do at the moment for end-to-end testing. And I'm not sure they do it. I know they have a lot of kernel testing, for example, but I don't know if they do automated graphical testing or if it's still manual. I mean, the QA team, they have a QA team. Maybe they're doing it manually. Alpine, the same. I think it's probably manual. And I mean, if you update once every 6 months, manual testing is not that bad, right? So Ubuntu, they have the 6-month cadence, so it's not so bad. If you want to update every day, that's when the automation gets more helpful. So OpenSUSE have Tumbleweed, which is a rolling distribution, and that's what they developed this tool for. And it's much easier to make a rolling distribution if you don't have to test every single day manually. Okay, so...